So, good morning, guys. I'm your educator Suyash. We will be diving into deep learning. So, this is our day one of deep learning. So, day one of understanding the basics of deep learning. So, first, I will give you an agenda and overview of what we will cover today. So, I can add a page here. Let's add a page here. So our agenda for today is agenda. Hope you are liking my writing. Overview. It's overview. So we will be covering. First, we will be covering our main topic is what is deep learning. What is deep learning? DL. We can call it DL. How deep learning works. Then we will be covering the difference between DL, ML, AI, and LLMs maybe generative AI and more things. And in DL we will be then later on covering what are computer vision, what is NLP, what is NLP, LLMs, and more things inside DL. So what is first we can write here that what is the key differences. The key differences of machine learning, ML, and DL. Then we will be covering what is the difference between supervised versus unsupervised learning. This you must have covered in your ML if you have studied ML. I hope you have know basic of ML, the basic statistics of ML. And then we will be covering real world applications with a few examples of what tasks we can do using deep learning. So here we will be covering real world applications of deep learning. So this is the agenda overview. This is our tasks for today. So now we can begin with the definition. What is the definition of deep learning? So deep learning is a subfield of machine learning that uses algorithm called artificial neural networks, ANNs. This is a very fundamental things. ANN is the most fundamental, then we move towards CNN and then RNN. Let's get the brief of these. This is ANN is actually artificial neural network, and then we can move to convolutional neural network. Convolutional network, and this is RNN, which is recurrent neural network. So deep learning is a subfield of machine learning. It is a subfield of machine learning that uses algos called artificial neural network. So what is meant by subfield? Here we have a chart, we can say a picture, schematic diagram of this, and here you can see that artificial intelligence is the superset, AI is the superset, and machine learning and then DL is a subset of AI, and DL is a subset of machine learning. So we can see the difference later on. First we go through the definition. We will go line by line, so this must not be the problem in case. So deep learning is a subfield of machine learning that uses algorithms called artificial neural networks structured in layers. You can see here, this is a neural net. Neural net is the short form of neural network, so we can write it complete neural network. So this is the neural network. So structured in layers to automatically learn hierarchical representation from data. Deep learning is particularly effective in modeling complex high dimensional data such as image, video and text. So basically DL deals with high complex data where there are many parameters to handle, many dimensions to handle, where there is data from different parameters and then we do feature extraction from it. We get feature extraction automatically from this neural networks and from the layers we get. So you must be thinking why it is called deep. What is the thing which makes it called as deep learning? Why is it called deep? So what's deep in this thing? Why it is called deep learning? The basic thing. So the term deep refers to multiple layers in the network. Like this first layer is called the input layer, as you can see, and then we have hidden layer 1, hidden layer 2, hidden layer 3, and then output layer. And there can be as many as thousands of hidden layers, many thousands of many layers, multiple layers, not just 1, 2, 3. It can have hundreds of hidden layers, and big neural networks, hundreds of layers can be present. So each layer, so the work of each layer is basically it can hundreds of layer, and the work of each layer is to extract features, like starting from simple features. Like in case of a convolution neural network, we can say that simple features which can be extracted are like edges. Like suppose I should show you CNN explainer. This is a little different topic, but we will be covering that too also. So I am just showing you what is CNN. So I have this open, CNN explainer. So what is the hidden layer and what hidden layer does? So this is a neural network of it is a convolutional neural network. So this is the first hidden layer which I clicked. So convolution happens, and then we can click on as many as layers. There are many layers in between, and then we have output. You can see this is the output. At the right side top corner it is written output. You can see output, and there are many convolution layers with activation function ReLU, and there are different channels, RGB. This will be taught in later. We only will be teaching you this part also. So this is red label, green and blue. This is basically the images are formed from RGB. We have a one dimensional image like grayscale image, and then there are 3 dimensions, RGB, red, green and blue. So as you can see, there is a first hidden layer. So there must be some feature extraction. Some features are extracted. Like basically in the first layer, the feature extraction works like we will be extracting some basic features in images. Like in this cup, as you can see, the first layer, the first convolution, the first hidden layer will extract some edges, some lines, some basic features. Like if there is an image of a man, suppose this is your man. Yeah, I'm very bad in drawing. Leave it. Suppose there is a ball like this, like some basketball type of thing. Then in first hidden layer, some edges features will be like this line may be extracted, this line may be extracted, or some line will be. And then in another hidden layer, some more complex features like some part of the ball will be extracted, and in the final output, whole football will be extracted from it. Like we can see from here, like espresso. So basically this is we trained this model. Now basically I can tell you what's happening here. So it's like a classification problem, and we are solving this classification problem. So we trained a model, and basically it has to define what the like cup we passed as an input and what is the output. So we passed this, and then the RGB was divided 3 dimensions, and then it gives the answer like espresso, maximum probability. So basically this is a classification problem, and probability is coming. So there must be a value, which is, I think it is not written the value. So if we pass a bear, cola, red panda, so red panda is visible here. So basically in first layer, as you can see, some edges of the panda, you can see some edges are obtained, and then more complex features gets obtained, and then slowly a whole image is formed, and then the classification problem is solved. They give the probability of what type of classification. Similarly it is done in everywhere. So now we can move. So basically you understood what is deep in deep learning, why it is called deep. Because it has many hidden layers, many complex hidden layers, hundreds of layers that are present. So actually I have written this also in notes. You will get what do early layers do, what does middle layers do, and what deep layers do. So if you didn't understand that CNN and feature extraction like edges in hidden layers, then there is no problem. We will be continuing our CNN in week 7 or week actually we have the timeline, so we will be doing those things in week 7. So there is no need to worry about it that you didn't understand. It's okay, it's fine. So what the hidden layers do, what the early layers do, and what the next layers do. So it is also taking examples from CNN also only, but you can understand these things. Like I will read this. In the first few layers, the network typically learns low level features such as edges, corners, textures, or basic shapes of the image data. And then middle layers will understand low level features, more complex, which are like detect textures, shapes. Like from edges we move to shapes, so that middle layers will understand. Like if we say this is the early one, and then this is the middle one, and then it is the end one, which is high level feature extraction. So this ending layers we can say. So in later on deep layers like end layers, whole recognizing it does recognizing of complete object. It understands everything. Like if we are doing a NLP task, natural language processing, which we say computer vision task, or any other textual data, speech detection, any task, then in final layer it understands everything. So this is a black box model actually. So we are building the intuition what happens on later layers, and now there are many like CNN Explainer and many type of gateways platforms which we can use to understand what's happening. This page I can attach. It is open source, so you can read and understand what's happening inside there. You don't have to scroll downside. You can just click and understand. This thing is accessible and it's open source, so we will attach a link to it, and you can go and understand what's happening. You don't need to go down scrolling it, because CNN is later on topic, but you can understand what is done in hidden layers, what is happening in layers. So this thing we covered, what is DL and how DL works. Two things we have covered now, and key characteristics we can cover now. What are the key characteristics of deep learning? So deep learning networks can learn non-linear relationships due to use of different activation functions, right? Like ReLU, sigmoid, and tanh. So activation functions are used to to get non-linear, in ideal world there is no linear data, there are non-linear data only. So we use ReLU, sigmoid and tanh, and there are many more activation functions which will be used in our models. Actually this we will be covering in our next day 2 lecture. We will be studying few activation functions, so this will be automatically covered there. We don't need to dig here. And what are other key characteristics of deep learning? Automatic feature extraction. Yes, this is the very good thing. This we should study. Like if you have studied machine learning, we like in machine learning, if we give input of like a dog cat classification, so basically we give what is the size, what type of face, like we must be giving like nose wetness or color, feather color, and basically size, color, maybe paws, and what more differentiate between, like maybe whiskers too, and the whisker sizes basically. So these are the parameters which we give to a machine learning model. This happens in machine learning if using machine learning. So in machine learning we are giving features, like we know the features of a cat and a dog, and we make a list close to that, like dog have a bigger size, like a weight can be also be a factor, like generally dog weights more, so a weight can be also be a parameter. Generally a dog appears bigger if we are considering a cats like that street cats, not the cats like tigers and all. And if we are considering cats which we generally assume as a cat and say, and dog and cat, if we compare, then we generally see weight of dog is large, big, and cat is lesser, and size of dog is big and cat is lesser. Similarly, we can differentiate between many other factors like color, paw size, whisker size, and maybe any other characteristics, and then we make a list of it and fill the list, and then we give to our machine learning model, and then these are basically the features or parameters, we can say, which we give to our machine learning model. And then parameters, actually, sorry, spelling, pardon me. So these are the features or parameters which we give to a machine learning model to predict, like the model will be trained according to these features, and then if we give another set of data to get the output, we get the machine learning model learns, or it may be like if it will be a two-dimensional, if we say, suppose there is a two-dimensional like weight or size, then dogs may be here and cats may be here. Weight and size. Actually it is little, if I make weight here and size here, and if we say that dogs and dogs lie with on larger weight and larger size, dogs are basically more have more weight and bigger size, then we can say that dogs are here. X is representing dogs and O is representing cats. So basically this is simple, like two parameter classification. We are having weight and size as the parameter and we are classifying it, and if we give another test case, test data set or test case, then according to this is basically a linear regression model, and accordingly it will be telling whether a new feature or a new data or a test case qualifies whether it is a dog, whether it lies above this linear regression line or below this linear regression line, and it will be classified accordingly. So now this is what we do in machine learning basically. Now what brings change in it, and how deep learning works. So deep learning is easier in terms of this, because we are not doing feature extraction, we are not doing whole data processing and all. We are just passing a photo of a cat labeled as cat, obviously in supervised learning we are labeling it, and dog, basically a data set. We can call it a labeled data set, that this particular photo of dog is labeled as dog, and this particular photo of cat is labeled as cat, which is labeled data set. So a whole data set of dog and a whole data set of cat, and the model is automatically trained. We just pass this and to the model, and neural networks are automatically trained. They automatically extract the features. We don't extract the features by manually passing it. They automatically extract the features, and when we give a test case, then they classify it. If a test case is passed to the model classification problem, then they classify. So this is the basic difference between this can be considered as the difference between machine learning and deep learning. So this automatic feature extraction is a very, very important factor which differentiates between machine learning and deep learning. Next, we move to scalability. Now, in earlier times there was a very less data available. Now with time, with progress, the data set availability is increasing, and now data sets are open source and they are available for everyone to look and do model training. So one more difference between machine learning and deep learning is that deep learning requires a lot of data. It requires literally a lot of data to train the model, to let the model understand what our needs and what we want. So scalability, as the size of data set increases, deep learning models improve with additional data, while other models tend to plateau. So this scalability things, I would like to show you a picture. I have a picture actually which I saw when I used to study. This picture. So you must be knowing ResearchGate. They are mostly people publish their the professors or research scholars, MTechs, masters publish their paper. ResearchGate is a platform we can look those papers. So this is the amount. This is the graph which which I wanted to show you. So if you look at the x-axis, amount of data is given and the performance is given. So earlier time it happens that when amount of data was very less. So this part, actually I cannot place my pencil, the electric pencil here, but I am zooming it so that you can understand this part of sorry. So this part, basically when the data was very less, so it used to happen that machine learning algorithms worked very good, like performance you can look. But as the data increased, when the availability of data, amount of data increased, the performance of deep learning model was better. So deep learning model produced more better performance. So now, as with time, as the scalability and the availability of data improved, deep learning models improved working. So this key characteristic is also very important, how, and this can also be included in difference between machine learning and deep learning, as we can say that as the availability of data increased, deep learning algorithms efficiency, performance and everything got automatically increased. Hope you understand this scalability. This non-linearity we will be covering in day 2, so don't worry, everything will be covered in detail. Now we move to our next topic. Actually I have this, sorry, we looked there. I have this in our notes. We have this amount of data, deep learning and traditional machine learning algorithms and predictive performance. We have this. So this can be covered in scalability. As the scalability and availability of data increased, our deep learning performance increased. So this can be covered from that. That's the difference also between machine learning and deep learning, and that is the key feature of deep learning. So examples of DL applications are object detection in images and voice recognition, autonomous driving, self-driving cars, which we say self-driving cars, like Tesla, and language translation, which also can be considered. Okay. So now this machine learning, difference between machine learning and deep learning. So first we will go through definition, and then we will read all this and understand one by one, points by points, and then we will be studying supervised and unsupervised learning. So I hope our agenda overview, what is the difference. Now we are on this agenda, our third agenda. So what is the key differences of ML and DL, and then we move to the definition. Machine learning, a field of AI that uses statistical techniques and algorithms to enable computers to learn from and make predictions on data. It involves training a model on data and use it for tasks such as classification, regression, clustering, etc. So these classification and regression come under supervised, and clustering comes under unsupervised, which we will be covering. I will be telling you. And you must have studied machine learning. If you are studying deep learning, you must have the knowledge of a little bit knowledge of machine learning. So machine learning is basically a subfield of AI, which is called artificial learning. I will be adding a few things, more diagrams. I will be telling. I will be adding in next day 2 lecture, of what transition. If you want, I can add the history behind it and what changes which we got. So let's move. What are the key differences? And deep learning is a subset of ML. So it is a subset of ML that uses artificial neural networks, which I told, to model and solve complex tasks. DL excels in tasks involving large amounts of data. Availability of data hence becomes important, particularly when dealing with unstructured data like text, images, text and speech. So in ML we have includes, now the key differences starts from here. So in machine learning, supervised learning is a thing, unsupervised learning is a thing, and then reinforcement learning. We will be covering the difference between supervised learning and unsupervised learning in the later part. Here we will be considering, so no need to worry. And then we have DL. I told you about convolution neural network by CNN Explainer, which I showed you. We will be adding the link also. And then we have recurrent neural network, RNNs, which we will be studying in later weeks, like maybe week 8 or week 9. And then transformer models for natural language processing tasks and building LLMs. Transformers can be used to build LLMs. So basically LLMs are large language models. This we will not be studying here, but I will be giving you some key points to take. So DL primarily based on neural networks, neural nets, especially deep learning networks (DNNs), which consist of multiple layers of interconnected nodes. Actually, these are hidden layers, which I told. These are hidden layers, and this single things like this, blue dots are called neurons. So this is the structure we will be studying in day 2, types of neural network. We will be covering these things. So we are just now in machine learning and difference between machine learning and deep learning. So this also I told you, if you remember, data requirements. Machine learning can work with smaller data sets. When data is less, the performance of ML increases, and when data is more, then performance of DL increases. So this is stored in this theory. Some traditional ML algorithms such as decision trees or linear regression perform well on smaller data sets. Okay, and DL requires a large amounts of data to perform very well. So when the data increases, then of course, obviously, the performance of deep learning or DL increases. Deep networks have a large numbers of parameters, and training them effectively requires a lot amount of data to avoid overfitting and to learn robust features. And to learn robust features, we have also understood in automatic feature extraction. They extract the features automatically. We are not giving every feature and data, and then it happens automatically. Sorry. Like this, feature engineering. Here comes the topic. Like, often requires manual feature extraction. ML often requires manual feature extraction or feature engineering, where domain expertise is used to select the most important features for the model. So basically, when we are training machine learning model, we need to have that domain expertise. Like if we are doing skull stripping, so basically skull stripping is a technique when MRI dataset. In MRI dataset, we have brain tissues and non-brain tissues. So in skull stripping, basically we are segmenting. Segmenting means we are just trying to get the brain image of that MRI. So we will be needing a radiologist for machine learning training part. We will be needing to understand what are the features for extraction. It may be the gray matter in brain, it may be the cyst, the different brain tissues. We need to understand every bits of it for manual feature extraction, like what comes inside the brain and what type of tissues we have to consider them into brain tissue and non-brain tissue. So basically, we need to do feature extraction, manual feature extraction. Like I told you in that cats and dog classification, that we manually understood like weights and size of cats and dogs are some features. So we are understanding those features. So domain expertise is required. Like in skull stripping, a radiologist must be needed to tell us what our domain knowledge of it. But in DL, it's easy, it's automatic feature extraction. Yeah, we need a domain expert to understand, but still deep learning models automatically learns hierarchical representation of features from raw data without the need of manual feature engineering. So just we pass the data set in the model, and it somehow just extracts the feature on its own. Then the other difference between DL and ML is computational power. So ML generally requires less computational power compared to DL. Classical ML algorithms can be trained on standard computer without specialized hardware. Okay, it's okay, it's fine. Requires significant computational resources, especially GPUs, graphic processing units, or specialized hardware TPUs due to complexity and size of neural networks. So basically TPUs are tensor processing unit. Now hardwares are now including TPUs also for processing. So DL requires significant computational resources, and machine learning doesn't require much of the computational resources. Now that's why we can see the rise of NVIDIA GPUs, NVIDIA RTX 3090, now it's 5070 or 5090. So basically the requirement, actually this is also a topic to study, like how we realize that parallel processing of the data in GPUs, like GPUs were earlier used for games, playing games, for high resolution games where resolution is very much required, and then we realized that we can use this parallel processing in our deep neural networks, like hidden layers are working parallelly, different layers of different neurons are processing the data. So we realized that we can do the thing similarly, like in games parallelly the data are processing, we can do the same thing in deep learning. So GPUs were included. Training time, actually this because of this process, pardon me, give me a few minutes, I just want to drink water. Yeah, so I told you about computational power. Basically deep learning algorithms require a significant processing computational resources because it is training on large data sets, and we need to parallelly process that data set because it is very large and it takes a lot of time. Because of this, the training time of deep learning models are very much. So we can read this also. ML typically faster to train because the models are simpler and don't involve as many as parameters. Takes longer. Deep learning takes longer to train due to the complexity of the networks, the number of parameters, and the need for larger data sets. Okay, good to go. I hope you understand the computational power and training time between, and the difference in ML and DL. So now we move to other point of difference between ML and DL, interpretability. As I told you earlier, I told you that it is a black box model. I think I named this term. Actually, I named this term earlier. That we know that these are the different layers, hidden layers, and then but we don't know how the weights are assigned. You will be studying what are weights and what are biases are assigned, how things are working inside it. We don't understand. In recent times, a new field has been opened, like explainable AI, where people are looking to make this black box model into turn these black box model into white box model. So basically in black box model they are harder to interpret, while techniques such as like saliency maps or layer wise relevance propagation can provide some insights. So these are basically the methods which they must be using. Actually I don't exactly know what they are implementing, so this I can tell you later on. When we move in this course, I will surely cover the parts of saliency maps or layer wise relevance propagation. So DL models are typically less transparent than traditional ML models, and if you've studied ML models, like in decision tree we can make trees, and linear regression we can understand how things are getting divided. We can get in linear regression we can get the slope and the part where it is intersecting the x-axis, that we call constant part. So we get the equation, we know that those things. So this is the difference between ML and DL, interpretability. We don't know what is happening, but in ML we know what is happening. Like in linear regression we get the slope and we get the constant where that linear regression line is cutting the x-axis and the y-axis. We can get the differences, we can get what is happening inside it. we can plot using maybe matplotlib or plotly to get the features if it is 2-dimensional or 3-dimensional. It is hard to get 4-dimensional interpretability, but still we can get in 2 dimension and 3 dimensions. Performance on complex tasks. ML performs well on simpler tasks or tasks with well structured data, tabular data. So basically ML works in more better in statistical. ML is basically, it's about statistics, mathematical statistics is implemented, and DL more of neural networks are implementation of neural networks. So we can write this thing, more of statistic, and DL is more of actually I wrote the wrong spelling. What is the spelling? Statistics. DL is more of neural networks. So DL outperforms ML in more complex tasks, especially those involve unstructured data as image recognition. So basically in ML we need to do EDA, which is exploratory data analysis. Here we do data processing basically, and in DL we can give unstructured data and it performs just. So for complex tasks we prefer DL for more. Examples of basically these are examples of applications in between ML, difference between ML and DL. So ML is used for spam filtering. DL can be also used for spam filtering, but ML, if we in DL if we use NLP, and then if we make a model in using NLP, then spam classification, and then we can use DL also. Basically DL can be used for spam filtering and all, but the problem, but why we will not use, because some places we will not use DL and we will use ML, because DL requires a lot of computational resources. So why to waste it? If the things can happen using ML, then why you will go for DL? So basically spam filtering can be happen using a DL, but we are using here, we are doing it using ML, machine learning. So both things happen, but still we are making a key differences. Predictive maintenance using structured data from sensors to predict failures. Actually my pencil charging, yeah. And then customer churn prediction. I can show you a model of it on Kaggle which I made. And then deep learning, we as I told you, self-driving cars, image segmentation, object detection, and many things. In image segmentation we have semantic segmentation and instance segmentation, and we use speech assistants like Siri, Alexa using RNNs or transformers. They are made of now deep learning is also OpenAI, which we use chat GPTs and DALI, and Meta has its own. So basically these are made using deep learning. Medical image analysis like skull stripping, which I told, where we are segmenting brain tissue with non-brain tissue in MRI scans. So basically the key applications, these were the key applications which we covered. And examples of algorithms, if you have studied ML, you must be knowing linear regression, logistic regression, decision trees, support vector machine, SVMs, k-means clustering, and many like PCA, KNNs, and many more. And in deep learning, as I told, convolutional neural networks, recurrent neural networks, generative adversarial networks, GANs which we say, and transformers, BERT, GPT models for NLP. Those were the examples. Now comes supervised versus unsupervised learning. So we will go through the definition, and then we will be completing this day 1 lecture series. So basically, supervised versus unsupervised learning. Supervised learning definition. First we go through definition. In supervised learning, the models is trained on labeled data set. In supervised learning, the models is trained on labeled data set. It learns a mapping from input to output based on labeled examples: classification problems, sentiment analysis, image recognition, regression problems, predicting house prices. And unsupervised learning, in unsupervised learning, the model is given data without labeled outcomes and must learn patterns or structure in data itself. So it's very much self-explanatory without labeled outcomes, and if I mark the exact location of that, it learns from input to output based on labeled examples. So the application in from unsupervised learning is clustering and dimensionality reduction, or PCA. So there is this thing, supervised learning, like as I told, if we pass, like cross if we consider as dogs, and O or 0 is considered as cats. So basically when we pass these things, we label, like we label that this thing is cat and this thing is of dog. But in unsupervised learning, we don't label them, we just pass and let the machine, that model, to understand it on its own. Okay, so basically if we are doing this in deep learning terms, then if we passed pictures of dogs and cats, so if we pass pictures of dog and cat, then we got we labeled them and we sent them to the model, and it gives the prediction of it. And in unsupervised, we didn't label it, we just pass and let the model learn it itself. So we get the answer, but the model learned itself, we didn't give labeled data to it. At the end, we move to applications of neural networks. Healthcare used in diagnosis disease from medical imaging, finance fraud detection, credit card transaction, marketing prediction, predicting customer behavior, and NLP uses in virtual assistants like virtual chatbot, self-driving cars, like perception models, and maybe road planning models, or path detection, like in if there is a pedestrian walking in left or side, basically the model follows the path, exact path, the road, traffic signs, etc. So we completed with our day one of this thing, deep learning. By understanding the basics of deep learning, we covered the basics of deep learning day one, and agenda overview. Let's look at what is the difference of ML and DL. We completed. Supervised versus unsupervised learning we completed, and in supervised versus unsupervised learning we will be looking at the models, and we will look how supervised versus unsupervised learning model give results. Generally these labeled data are more beneficial because the dice coefficients of labeled data are the supervised learning are more, so performance metrics of supervised learning is more. We will be looking this thing in more detail by looking at the models, and then we also looked at real world applications of deep learning. So thank you guys for today's lecture.